We're going to go through a few of the review problems, the ones that take a little bit of calculation or more thought than ones that just require regurgitation of information and definitions. So in question 1, this will be a good one to do some calculations, and it's always good you can do the calculations right on the paper. You're going to have 9 grams of water. We want to get rid of grams and get to moles. So I look at my periodic table. There are 2 hydrogens, each of which are about 1, because we're doing stuff without calculators here on our paper 1. And then oxygen, there's 1 of them, and weighs 16. It's going to be 18. Notice again that we're not using calculators, so it gives us really nice, easy numbers to deal with. 9 divided by 18, that's 1/2. Times, we want this in molecules, so I need to use Avogadro's number, 6.022 times 10 to the 23rd molecules for every 1 mole. And we see grams cancels out, grams cancels out, moles cancels out, moles cancels out, I'm left with molecules. So half of 6.022 times 10 to the 23, my answer is roughly 3.0 times 10 to the 23, which is answer D. Same sort of thing with question 2. Start out with our given, 8 grams of CH4. We want to get to the volume of the carbon dioxide. So I'm going to do 1 mole on top to get rid of my grams of CH4. Again, I go to my periodic table. I have carbon, which is about 12. Hydrogen, there are 4 of them, each worth about 1. So I get about 16. Again, notice I've got nice, easy numbers to deal with. 8 divided by 16 is 1/2. Then I need to look at my balanced equation. I'm getting rid of CH4. The coefficient in front of that is 1. So 1 mole of CH4. And I'm looking to get to the CO2. So 1 mole of CO2 goes on top. Again, for my balanced reaction. Then I'm looking for the volume of gas, so I need to remember that for every 1 mole of gas that I have, in this case the CO2, takes up a volume of 24 decimeters cubed, and that's actually given to you, so it wasn't one that you had to memorize for this. Grams cancel out, moles cancel out, moles of CO2 cancel out. I'm going to have decimeters cubed in the end. Again, nice and easy. 1/2 of 24 is 12. That is answer B. The next one also requires a little bit of thought and calculation. It says that we have 28 grams of metal M, so one that we don't know anything about, and 8 grams of oxygen, and they form MO. So we have a 1 mole to 1 mole relationship because they each have 1 to 1 there. So I can use that information, and I can use my information from the periodic table and the information that's given to me to figure out what I have here. I know I have 8 grams of oxygen, but I want things in moles again. So 1 mole of oxygen on top. On the bottom is the mass of oxygen, 16 grams of oxygen. So I'm going to have 0.5 moles of oxygen. Again, I see this relationship of moles to moles. So if I know that my mass of M, this weird substance that it's not telling us what it is 28 grams, I can set up like I normally would, but this time I don't know the mass of X. That's what I'm looking for. 1 mole of M goes on top, and that is going to be equal to my moles of oxygen. So I can rearrange this equation, and I get 56 of cross multiply would work just as well for this one. 56, which is answer C. We see the same sort of thing for question 4. I'm starting out with 80 tons of iron oxide, so the Fe2O3, and it has a molecular weight of 160. So 80 times 1 mole over 160. And again, that's of the Fe2O3. I don't want Fe2O3 though, so I have a mole ratio here. 1 mole of the Fe2O3 for every 2 moles of iron. Take that one step further. For every 1 mole of iron, the mass from the periodic table is 56 grams. Or here we're doing tons. So moles cancel out, moles, left with my tons, 56, which is answer B. Number 5, we're looking for isotopes, so we know that we need to have protons being the same, neutrons being different. The only one from the chart there that works for us is L and Q. Therefore, the answer is D. Number 6, we have 2 isotopes, 79 and 81. There's a few ways to tackle this problem. Probably the easiest would be to plug in the relative charge or relative percentages that it gives you. And I got the answer to be D. Alright. 7 is a regurgitation type problem. So is 8. And those answers are C and B respectively. Number 9, graphite's always going to conduct electricity. Liquid ionic substances will, that means they're in the molten state. Aqueous always will, that means that they're dissolved in water. So the only one that will not is C, CaCO, solid. It would if it was aqueous or molten, but again, it's solid, so it won't. Number 10, this one can use a little bit of drawing. So we have water. Draw that out. It has unbonded electron pairs, so this is definitely polar. Hexane is a nice carbon chain. With hydrogens all around it. No extra electrons anywhere, so this is going to be nonpolar. But we'll check the other ones. Propanone has a double bond with an oxygen with lots of stuff on it, so that one will be polar. And then ethanol has an OH group, so that would be polar. So the only one that's nonpolar is B. Number 11, drawings would be helpful for this one too. We are looking for the smallest bond length to the largest. So smallest would be if I have a triple bond, followed by a double, followed by a single. Single is going to be the longest. So I can draw them all out. N2H4 would have a single bond with some extra electrons on it. N2H2 has a double bond, and N2 has a triple bond. So the answer is B. N2, N2H2, and then N2H4. Again, we would want to draw for number 12 my Lewis structure, and I would want to identify the molecular shape. So NH3 has 4 electron clouds, but only 3 of them are bonds, so it is trigonal pyramid. The next one, CO2, is a linear. That's our easiest one, it's 180 degrees. So we know that's not our answer. And then finally, carbon, hydrogen, and 3 chlorines. That is 4 electron clouds, all 4 bonded, so tetrahedral. And B is our answer. 1 and 3 are the only ones that have a bond angle of 109.5 or less, because this Roman numeral 2 is linear. Number 13, we're thinking of V1 over T1 is equal to V2 over T2. And we want to make sure that our temperatures are in kelvins, so we're going to take our T1, 32 plus 273 is equal to 305 kelvins. T2 is equal to 64 plus 273, which is 337 kelvins. Our volume is decimeters cubed for the first one, so I have 1 decimeter cubed times my T2, which is 337 Kelvin, divided by 305 Kelvin, and I get my answer 1.1, which is A. Okay, 14 is a regurgitation, it's C. 15, we take our equation Q is equal to mc delta T, and it's all going to get plugged in. The only difference with this is that we're dealing with calorimetry, so we're dealing with all of this for water, and then we're going to divide by the mass of our metal. So A is the correct answer for that one when I plug that all in. This is an older test, an older syllabus, so 16 will not be on the test. 17 is regurgitation and is B. 18. We would flip the first reaction and multiply it by 2. So I would get 2 SO2 goes to 2S plus 2O2. So my delta H would also be multiplied by 2 and flipped, so it's now positive 600. My other equation I'm going to keep the same, so 2S plus 3O2 goes to 2SO3. My delta H is going to stay the same since I did nothing to the equation, negative 800. I can double check, make sure I did this right. My 2 S's are going to cancel out. One of my O2's is going to cancel out here, or 2 of them are going to cancel out there, leaving me with 1. So I'm going to have 2 SO2 plus O2 goes to 2 SO3, and my delta H will be the sum of these values, which is negative 200. So my answer is A. 19 is a regurgitation. The answer is A, because 3 is dealing with rate. 20 is also regurgitation. It is D. 21, I need to think through a little bit. I want to increase the sulfur trioxide. So I look at my equation. I have 2SO2 gas plus O2 gas in equilibrium with 2SO3 gas, and my delta H is negative. So I want it to shift to the right. It's the shift I'm looking for. If I decrease the concentration of oxygen, like it gives me in option A, that means that I'm putting off my equilibrium like this, which means it would have to shift to the left to get back to normal. So A is not our answer. In B, we have to look at the moles of the gases that I have on either side. I have 3 moles of gas on my reactant side, 2 plus the 1 there is 3. I just have 2 moles on my product side. If I'm increasing the pressure, I'm going to go towards the side that has the least number of moles. So B is our answer. If I used a catalyst, it would just decrease the activation energy, so the rate would increase in both directions, so that wouldn't do anything to the equilibrium. And then if I increase temperature, that goes towards the endothermic side. This, since it is negative, is exothermic, so it's going to shift towards the reactant side instead. Number 22, we are dealing with a change from 3 to 6 on the pH scale, so 3 to 4 times 4 to 5, 5 to 6, oops, I'm doing 10-fold change each time, means I have a change of 1,000, and that is decreasing the factor of the concentration of H+, because I'm getting closer to neutral, so I'm decreasing that delta H by 1,000, so our answer is C. 23, also from the old syllabus, will not be on the test. 24, we're going to look at the oxidation numbers. Specifically for chromium, we want to find the one that it is 3. So in Cr04 to negative means my overall charge is equal to a -2. My oxygen is always a -2, and there's 4 of them, so I have -8. And this is what I'm looking for, my chromium, so that's, we'll put as an X. When I rearrange that, I find that my X has to be a +6. So that is not my answer. The second one, Cr2O7 to negative, I have 2 chromiums this time, so 2 times my unknown. Oxygen again is always a -2, so -2 times 7 is a -14. It's going to be equal to, again, my overall charge of a -2. So I rearranged that, my X is again a +6. So not my answer. Cr03, this has no charge overall, so it's going to be equal to 0. Again, oxygen is always a -2, so -2 times 3 is a -6. The chromium is what I'm looking for. There's only one of them, so it's just X this time. That means X is equal to +6. So far, we're going to assume that the answer is D, but we're going to double check it. Cr, parentheses, OH3, net charge overall is equal to 0. The OH polyatomic ion is always a -1, and there's 3 of them, so it's a -3. X for the 1 chromium that I have there, X is equal to a +3. That is our answer, D. Okay, with question 25, we are looking for the one in which hydrogen is the oxidizing agent, which means the other thing is oxidized, which means it has lost electrons, so it would be more positive. That means that the hydrogen is being reduced, which means it is gaining electrons, which means it's going to become less positive or more negative. The only one that fits both of those requirements is A. Okay, 26, B is the correct answer. 27, we're looking for structural isomers of C5H12 hexane. So we could have it 3, 4, 5. We could have it like that. We could have it with 3, 4 in a row, and then a carbon coming off of either one of those two carbons. It would be the same either way. And then finally we could have 3 in a row with carbons coming off of both carbons, extra carbons coming off the middle one. So B, 3 isomers is all. 28, A is the correct answer. 29 will be on the IB exam, not on the final for second semester students. It is B. And then question 30 would also be on the IB exam. The answer is A.